Hello everybody, hope you're all doing well, and today we shall be covering method of differences. So, if we are given that ur is equal to f function of r minus f function of r plus 1, then we can presume that the summation, when we're going up to n, starting with r equals 1 of ur, is equal to the summation of the f function of r minus the f function of r plus 1. Now, we can represent this further by inputting r equals 1 here, and that will give us f of 1 minus f of 2, and when r equals 2, that will give us f of 2 minus f of 3, and when r equals 3, this will give us f of 3 minus f of 4, and so on and so forth. And going up to the to r equals n, which is our final term, as you can see here, we're going up to n. This means that we'll have f of n minus f of n plus 1. Now you may notice that some terms here actually cancel off. We have an f of 2 here and an f of 2 there, which means those will cancel off with each other. Same for f of 3 and f of 3. And you will actually notice a pattern that if you went on even further, your f function of r plus 1 on the right side cancels off with the f function of r below it to the left, just one down to the left. This pattern will actually repeat throughout, which means that we know the f function for n will cancel off when r is n minus 1 here, so we can cancel that off when we know that's gone. And this means we are left with two terms left, our f of 1 and our minus f of n plus 1. That means that the summation going to n of r when r equals 1 of ur equals f of 1 minus f of n plus 1. Now this is only a generalized example, and we shall actually cover some our very own examples as we go on, increasing in difficulty. So this is our first question. When r is equivalent to r over 2 times r plus 1 minus r over 2 times r minus 1, we can show that the summation of r is equal to n over 2 times n plus 1. Now, if you've done series, you'll actually recognize this as a formula you have to know, and we're actually going to prove it using the method of differences. So, we're going to start with r equals 1. Now this will give us 1 over 2 times 1 plus 1, which is obviously 2, so a half times 2 is just 1. Then we'll get minus 1 over 2 times 0, so it's just going to be 0. And r2, we'll do the same. We'll get 3 minus 1, r equals 3. You shall get 6 minus 3. And we can go down to r equals n, which will be our final term, and have n over 2 times n plus 1 minus n over 2 times n minus 1. And as you can see, terms do cancel off. 1 there cancels off with the minus 1 there. 3 there cancels off with the minus 3 there. And as you can see, there's this pattern emerging, which means that we know that this will cancel off with something on the upper levels, which means we can represent the summation going up to n of r, starting with r equals 1, is equal to minus 0 plus n over 2 times n plus 1. And of course, 0 is just something we needn't show, meaning that we've proved that summation of r going up to n, when starting with r equals 1, equals n over 2 times n plus 1. Now we shall cover a more difficult example. So moving on, here is our second example. The principle is very much the same, so if you'd like to pause the video and have your own go, see if you get it correct, I shall go through it presently. Now, presuming you've had a go, let's see how you've fared. So, we shall start with r equals 1, which means we'll get 1 over 2 times 2, so we'll have a quarter, minus 1 over 2 times 3, well, 2 times 2 is 4, 4 times 3 is 12, so we get 1 over 12. R equals 2, we'll have 1 over 4 times 3, 4 times 3 is 12, so we'll have a 12 there. 1 over 2 times 3, 2 times 3 is 6, times 2 plus 2, which is 4. 6 times 4 is, of course, 24. So, 24. When r equals 3, we shall have 1 over 2 times 3, which is 6, times 3 plus 1, which is 4. 6 times 4 is 1 over 24. And we shall get another term here. Our finalized term when r equals 3 will be 1 over 2 times 4. 2 times 4 is 8. 8 times 3 plus 2, that's 5. It's 1 over 40. And once again, we have terms that cancel off just the same as the previous examples. So a 12th there cancels off with a 12th there, 24th there cancels off with 24th there, and we'll get down to our r equals n, which will leave us with 1 over 2n times n plus 1 minus 1 over 2 times n plus 1 times n plus 2. And following the same pattern, so the first one here is not being cancelled off, which means the first one down here will be cancelled off. This leaves us with 2 terms left, which will be a quarter minus 1 over 2 times n plus 1 times n plus 2. Now, just for simplicity's sake, I'm going to dub this as x, which means we've got a quarter minus x, 1 over x, that is. So, let's simplify this. That shall equal, well, we're going to times by x over x here, I'm going to times by 4 over 4 here, meaning we're just timing by 1 overall. So we shall have x over 4x minus 4 over 4x, which basic fractions tells us that we shall have x minus 4 over 4x. Now we'll expand this, knowing what x equals here, and we shall simplify where we can. So, let's crack on. Well, this shall equal 2 times, looking like over here, n squared plus 3n plus 2 minus 4. And just for simplicity's sake, we shall leave it as 4x for now. Bring it down back over here. This shall equal 2n squared plus 6n plus 4 minus 4, meaning those cancel off, over our 4x. And this, well, what can we factorize out of 2n squared plus 6n? Easy, it's 2n. And this will leave us with n, 2n times n equals 2n squared, plus 3 over 4 times x, so we shall have 8 times our n plus 1 and our n plus 2. And this doesn't simplify much more except for the 2 here. We can get rid of that, and that will hit up our 8 down to a 4, which means, using method of differences, the summation of 1 over r times r plus 1 times r plus 2 ultimately equals n times n plus 3 over 4 n plus 1 times n plus 2. As you can see, nothing that is outside of your capabilities. Now let's move on to some slightly harder examples, shall we? So moving on. Here is our next part that we shall be answering. Now often when doing method of differences, you may find they ask you to express something in partial fractions. Now you may or may not have covered this yet, but I shall just briefly go through part A with you. So, part A, we have got 1 over r times r plus 2, and that, well, r plus 2, that will equal a over r plus b over r plus 2. Now if we times by r times r plus 2, this will give us 1 equals a times r plus 2 plus b times r. And here we have multiple choices on how we can find out the value of a and b. I'm going to use the example of substitution. So if we substitute r equals 0, this cancels off our br term, and we'll have 1 equals a times 2, which means that a will equal a half. Now, if we just input when r equals 1, we shall have 1 equals a half times 3 plus b. Now if we rearrange this, we shall find that b equals 1 minus 3 over 2, which equals 3 over 2 is 1.5, which means we've got negative a half. So when representing r over r times r plus 2 as partial fractions, we shall get 1 times plus 2 is equal to a, which is a half, so 1 over 2r minus 1 over 2 times r plus 2. And that will be important, as when we come on to part B, we must find the sum of the series of this, which we just expressed as partial fractions. So that means that our summation to n r equals 1 for 1 over r times r plus 2 is equal to the summation r equals 1 of our partial fractions here, 1 over 2r minus 1 over 2 times r plus 2. There we go. So if we start with our usual, r equals 1, we should get 1 over 2, so a half, minus and that shall be minus so 1 over 2 times 1 plus 2, 3 of course, times 2 is a sixth, so there we go, sixth. R is equal to 2, we shall get 1 over 2 times 2, that's 4, so a quarter, minus 1 over 2 times 2 plus 2, that's 4, 2 times 4 is 8, so eighth. When R is equal to 3, we'll get 1 over 2 times 3, so a sixth, minus 1 over 2 times 5, which of course is 10. And as you can see, we've now got some terms that will cancel off. We've got a sixth going off with a sixth here. However, this is different to our other examples, as the sixth is cancelling off some more. There's 2 layers down here, which means that we need to approach this slightly differently. So when we go down, we'll go to R equals n minus 1. This will become more clear in a moment. So that means we'll have 1 over, remember R equals n minus 1, so we'll have 2 n minus 1. Then we'll get minus 1 over 2 times n minus 1 plus 2. So that's just 2 minus 1, which is 1. So that'll be n plus 1 there. Then we substitute our R equals n in there. 1 over 2n minus 1 over 2n plus 2. So we know the terms in our right hand side column are cancelling off with terms that are 2 times below it on the left, which means we know that those will cancel off with terms up here. However, those will not be cancelling off with any terms because there are none after n. So we're going up to n here. So that means we shall get a half plus a quarter minus 1 over 2 n plus 1 minus 1 over 2 n plus 2. So we shall use my little substitution method just to make this easier. Have that equal x, and this is different to that, so we won't use x again, we shall use y. This means we have half plus a quarter is, of course, 3 quarters. And then we have minus 1 over x minus 1 over y. So using fractions again, we shall be able to find out that we have, we're going to have to times by x over x and y over y and 4 over 4. So this means we'll have 3xy over 4xy, which obviously cancels back down to 3 over 4, minus 4y over 4xy minus 4x over 4xy, which equals 3xy minus 4y minus 4x, all over 4xy. Moving on, this means we shall have 3 times x, which will give us 6n plus 1 times y, which will give us 12 n plus 1 n plus 2, so it's 12 n plus 1 times n plus 2 minus 4y, 4 times 2 is 8, 8 times the y, so n plus 2 minus 4 times 2, 8, n plus 1, all over 4xy. So this will give us, if we just bring this down to here where we have more space, we'll have to start expanding these and simplifying. So that will give us 12 n squared plus 3n plus 2 minus 8n minus 16 minus 8n minus 8 over 4xy. This will give us 12n squared plus 36n plus 24 minus 8n minus 16 minus 8n minus 8 all over 4xy. Now obviously things can simplify here, so this will still give us 12n squared, but now we're going to have 36 minus 8 minus 8, which will give us 20n. Then we shall have 24 minus 16 minus 8, which is 0, so we needn't put anything for that. Over 4xy. So if we factorize this a little bit, what are the highest common factor of 12 and 20? Well, 2 goes into both of them, of course, which will give us 6 and 10, but then we can get another 2 out of that. So we shall have 4n times 3n, which will make our 12n squared, and 4 times 5 makes 20, so we shall have plus 5 there, all over, and we shall finally expand this bottom bit here, so we shall get 4 times 2 times 2, which is 8 times 2, so 16, times n plus 1, times n plus 2. Now there's not much simplifying we can do here, but that 16 and that 4 can go. That'll go to 1, and that'll go down to 4, which means we've shown a summation to equal 3n plus 5 all over 4 n plus 1 and n plus 2. So that is a slightly more complicated example. Now I've only got one left that I want to go through, so start a new page and we shall look at our new question. So we've got more partial fractions again, that's to be expected, I suppose. So we're going to have 4 over 2r plus 1 times 2r plus 5 equals a over 2r plus 1 plus b over 2r plus 5. Now even I put a plus, but since we know we're going to be using a method of differences later on in this example, we actually know that shall be a minus. But that's fine. We'll just keep it as a plus for now, just to not confuse ourselves. So we're going to times the whole thing by 2r plus 1 times 2r plus 5. This will give us 4 equals a times 2r plus 5 plus b times 2r plus 1. Now, I mentioned before there are multiple methods for partial fractions. We shall now use the second one, just to mix things up, I suppose, if nothing else. So that means we know that a times 2r plus b times 2r equals 0r. So that is 2a plus 2b equals 0, which means b equals a equals minus b, or vice versa. And that is very helpful, because it means we only have to find out one of these constants. Our other equation is 5 times a plus 1 times b equals 4. So that's 5a, so this is equation 1 and equation 2. 5a plus b equals 4. Now you may recognize these as simultaneous equations, so we can substitute equation 1 into equation 2, which shall give us 5a plus b, where we know b equals minus a, so that'll be plus minus a, equals 4, which means we have 4a equals 4, a equals 1, therefore we can derive with equation 1 that b equals minus 1, which means when representing this as partial fractions, we shall have our 1 over 2r plus 1 minus 1 over 2r plus 5. Right, there we go. That's part A done. Now move on to part B, which I thought was rather unique in design. I've not seen too many that look like this. So we have to find the value of the summation of 4 over 2r plus 1 times 2r plus 5 when going up to 25, starting with r equals 16 to 4 decimal places. So let's get our method of differences hats on. So starting with r equals 1, we shall have 1 over 2 times 1 plus 1, which is just 2 plus 1, so we'll have a third. Then we'll have minus 1 over 2 times 1 plus 5, which is a seventh. When r equals 2, we shall have a fifth, minus a ninth. When r equals 3, we shall have a seventh, minus an 11th. And as you see, terms cancel off. 1/7 here, 1/7 there. This is one of those slightly more awkward examples again, meaning we have to keep an eye out on how many layers we're going down. So if we put ... down to r equals n minus 1, then we will be given that 1 is over 2 times this plus 1, which means we'll have 2n minus 2 plus 1, which of course will be 2n, so minus 2 plus 1 is obviously minus 1, minus 1 over 2 times n minus 1 plus 5, so that'll be 2n minus 2 plus 5, that will give us plus 3 overall, so that's 2n plus 3. So cancelling off 2 times down, this will cancel off when r equals 4, this will cancel off when r equals 5, and this will cancel off with 2 terms up, and we'll have r equals n, so we'll have 1 over 2n plus 1 minus 1 over 2n plus 5, and this will also cancel off. So that shall give us overall a third plus a fifth minus 1 over 2n plus 3 minus 1 over 2n plus 5. So we shall dub this x, we shall dub this y, and that will give us a third plus a fifth. So if we just do some timesing and some adding, we shall find that equals 8 over 15, and then we shall have minus 1 over x minus 1 over y. So we're going to have to times by 15 over 15, times by x over x, and times by y over y. This shall give us 8xy over 15xy minus 15y over 15xy minus 15x over 15xy, and this simplifies down back to what we originally had. But now we can add the terms, or subtract them even. So 8xy minus 15y minus 15x all over 15xy. So let's get down to some simplifying. So this will give us 8 times x times y, so that will give us 4n squared. We shall get 5 times 2, 10, 3 times 2 is 6, so that will give us plus 16n, 3 times 5, 15, plus 15, minus 15 times y, so that will give us 30n, minus 5 times 15, which of course we've 50, 25, 75, minus 75, then minus 15x, we minus 30n, and minus 15 times 3, which is 45, so minus 45, all over 15xy. So let's simplify this even further. That will give us, so we need to times 8 by 4. If you do 8 times 4, then you'll get 32 n squared. 16 times 8 is 128, so it's plus 128n. 8 times 15 is 120. Of course, we're going to use minus 8 from out of the term, so there we are. 120 minus 30 minus 30, that's minus 60n. And 75 minus 75 minus 45 will be minus 120 for 15xy. So that means that we shall have overall 32n squared, and of course 128 minus 60, well that'll be 68. 120 terms cancel off, so that'll be just plus 0 all over our 15xy. We can simplify this, so the biggest common term here is what, 4n? 4n, 8n plus 17 over our 15xy, and there is no common factor between 4 and 15, so there's no more cancellation there. So now we've got our summation to deal with, which is going up to 25 of r equals 16 for u r. Now this equals, if you remember your series, and maybe a proof by induction, this will equal summation to 25 when r equals 1 of u of r minus the summation up to 16 minus 1, so 15 when r equals 1 of u r. And since u r we have determined equals this here, it's just some substitution. So that will equal 4 times 25 times 8 times 25 plus 17, all bracketed, over 15 times 2 times 25 plus 3, all bracketed, times 2, 25 plus 5. And when you simplify this down, you shall get 1336 over 61215. And this roughly equals, because we're going to 4 decimal places, if you remember, This will be equal to 4 decimal places 0.0218. And that is method of differences. Well, I hope you all enjoyed, and hopefully it helped you if you were having any issues, or just confirmed your previous beliefs about how to do method of differences. And I hope you all have a good day. Cheerio.